Pipelines Integrity Management, and ILI, or inline inspections for pipeline, which is a non-destructive method, and I'll talk about that further down. And I would like to start with the contents of my presentation. I'll give a quick introduction to slurry long-distance pipelines. What are the unique features of these systems? Like Mr. Rao, also Hein touched a bit on the environmental impacts of slurry pipelines. Which slurries can be transported. It's not only limited to iron ore. We saw in the presentation from Falua that tailings is also something that we can transport, sludge, and so on. Also, similar to Mr. Rao, I'll be insisting on slurry properties, material characterization, and test work. The concept of pipeline wear, and then from there, the pipeline's integrity management, management inline inspections, and further down the line, ultimately, repair campaigns and replacement of sections of the pipeline. So as an introduction at Paterson & Cook, we define a long-distance pipeline as anything longer than 40 kilometers or any pipeline that is leaving the mine site area. And as you can imagine, this criteria results in unique engineering and also in unique equipment selection, mechanical equipment. Some of the requirements for a successful slurry long-distance pipeline system are test work on a representative sample, and this must be performed. I'll talk about that further down in my presentation. Additionally, the route selection, looking at constructability, that there are not slopes that are like too steep or areas that need massive excavations, and that the right-of-way, the section of the construction that is going to be used for the pipeline should be available. Dedicated SCADA system and leak detection system for the control room, hiring an experienced design and construction management team, proper planning and execution strategy to ensure that the design is not being significantly deviated from during the construction. And finally, some defining operating procedures to prevent any unexpected stoppages, damages, and how to operate the pipeline. Some of the unique features of these systems are advanced control systems, such as in this image that you see. These have highly automated sequences, such as the sequences for how do we start up the pipeline? How do we start up the pumps? What are the sequences when you need to operate and close and open one isolation valve? So these are highly automated sequences in this type of systems. Communication networks extending over large distances. Most commonly used is optic fiber to communicate between stations, and visual displays for optimizing the pipeline operations in the control room. Pipelines for slurry transportation are generally buried. There are some cases where pipelines can go above ground, but for buried pipelines, this requires the correct coating system, external coating for the pipeline, and cathodic protection to minimize the corrosion. These systems require a higher degree of equipment monitoring to ensure that the downtime is minimized, and the equipment, mechanical equipment, is generally selected for a longer lifetime than for other slurry pipelines. And generally, these systems include, as you can see in this reference image, some live hydraulic rail lines, getting all the readings from the pressures of the system, translated into slurry head, cameras for places that is more difficult access or to visualize the operation of valves. And regarding environmental impact, as has been repeated in previous presentations, the lifetime carbon footprint is lower compared to trucks and railways. Noise, dust pollution, road congestion, traffic accidents are eliminated. So there's significant environmental benefits. Another positive aspect related to environmental, social, and governance is that when one of these projects is developed, the local communities are also benefit. And there's also potential for wildlife, biodiversity to keep developing along the right-of-way. And this is an image of a recent project that you can see from the construction, how vegetation starts growing in the area of the pipeline. So what can be transported through pipes? Different types of slurries. Like in this image, you can see some samples of tailings, mineral concentrates, coarse material like sand, or products that sometimes come from the cyclone underflow. And finally, sludge, that can be a byproduct of a water treatment plant that can also be transported through pipes. So fluids, anything in between the ranges from 0 to up to 80% solids concentration by mass. And there's a number of factors that influence pumpability. So in slurry properties and material characterization, we always insist that the test work is needed in order to be able to design the optimal system. The test work should be conducted using representative samples and by laboratories that have experience dealing with these mineral slurries. As Mr. Rao said, sometimes mineralogy can change, and this affects not only the rheology, but also solids density, which is then a function of the solids concentration. Therefore, your density can be or can have a variation, which is important to capture. And as you can imagine, test work reduces the design and cost because it reduces the uncertainty that you can have. And it's not possible to predict slurry behavior just from particle size distribution. We need to do the test work. Even though that mines probably sometimes are very close to each other, the grinding equipment is different, therefore your product is going to be slightly different. So here I want to talk a bit about pipeline wear. Wear is the progressive removal of material or reduction, if we're thinking of a pipe, the reduction of thickness of a pipeline during its lifetime. And for us, wear is the combination of abrasion due to the slurry and the corrosion that can happen due to oxidation in the steel pipes. India has some existing iron ore pipelines, and obviously with time they're going to be aging. So how critical is to ensure the integrity of the pipelines during its design life? Do we know what is the present condition of these pipelines in terms of what is the wear and what is the, compared to when the pipeline was new? And with that information, can we produce a forecast to know when do I need to take action? Pipeline integrity management is the process of ensuring the safety and reliability of pipelines, basically preventing any failure in the system. These are programs and systems maintained typically by owner-operators that take account all the stages of the pipeline life cycle, from the design, construction, operation, inspection, and further down the line, if necessary, repairs and replacement. So what is ILI? ILI is inline inspections, and what we can use is intelligent pig tools that can measure existing thickness of the pipe. So with that information, you can tell how much the pipeline has worn out. It can also measure by ultrasound or by radiography where are the problems with anomalies, if the pipeline has any channeling in the bottom of the pipe or any dents. So that's very valuable information. As you can see in these examples, you can tell that in the first section of the pipeline, typically after a number of years, you have an increased worn pipeline. And then with this, you can start producing a forecast and get this into your pipeline integrity management to take action to prevent any failures in the system. Information that is needed to develop this integrity management plan: keep an updated database of the slurry properties, updated test work. It's also interesting to know what is the client organizational chart. We have noticed in a number of cases that sometimes there's no communication, for example, between the thickening area and the pipelines area. And this should be integrated because at the end, it's all affecting the final product that we're pumping. And if possible to do one of these ILI inspections with intelligent pigging tools, you can get all this valuable data and information to produce your pipeline integrity plan. And here is another image of how one of these intelligent pigging tools looks like that is about to be launched on the pig launcher. So if further down the line action needs to be taken, one of the first actions is to go for repair campaigns. Receiving the information from the ILI report, the pipeline is carefully excavated an exact location of anomalies is determined from the pipe spool well. And then whatever distance from the anomalies that need to be replaced, also looking at the pipeline from the clock orientation, it's possible to find these areas and proceed with the repair. Typically, the repair is considered a sleeve, and welding standards are carefully prepared and approved by welders practice exact welding requirements on water-filled pipelines before being allowed to weld the live pipeline. Once repairs are not possible, replacement of the sections of the pipe is needed. And as you can imagine, this is going to need a much larger mobilization, and it's almost like doing a construction of a pipeline by scratch. You also need to consider that you have an existing pipeline. Are you going to remove the existing pipeline and put this new section in the same place? Or do we have enough right-of-way to put it parallel to the existing one? And Paterson & Cook has been supporting some clients with these pipelines that they had a design life of 25 years, but now they've been operating for more than 30. So it's possible to keep extending the life of pipelines with a proper pipelines integrity management plan. So as a summary, long-distance pipelines are designed to operate at high efficiencies and include unique equipment and unique engineering. Test work must be performed during design and operation as QA/QC. I think this is very interesting for the Indian industry because we know there's going to be some aging pipelines down the line, and these intelligent pigging tools are of great interest. And the primary goal of pipeline integrity management is to prevent failures. Thank you.